Now let's look at the firm's decision on the perfectly competitive market. So in the short run, we do distinguish different categories of costs. There is fixed cost, there is variable cost. The reason for that is in short run, we have a certain inflexibility in changing certain factor of productive factors. For instance, the capital could be fixed since it'll take considerable long time for the installation of production lines. Okay, I'm just giving you one example why we observe fixed cost in the short run. And in that case, labor could be variable cost because it's relatively easier to hire more people or fire workers. Okay, so that's a short run scenario. In the short run, we do distinguish cost into fixed and variable. And here, let's look at this. If we were giving tours as flying commercial helicopters, in that, what's the fixed cost? What's the variable cost? Well, the fixed cost could be the facility itself, the machine, which is the helicopter here, right? The variable cost could be how many flights do you do per day, for instance? How many tours are you giving, right? How can we avoid a fixed cost? We do this by completely closing down and exiting the market, right? In that case, you just sell everything, wrap up everything, and sell the helicopter, say goodbye to this industry. That's a long run decision. That's an exit decision. Because in that case, you fire the labor and you get rid of the capital, right? So there's flexibility in both. That's a long run decision. But how can we avoid variable cost? Well, possibly that's a sick day. Possibly the weather is not good that day, right? Say if in that day you cancel all the flights, then you avoid the variable cost. You still have to incur fixed cost. Yes, the plane is still under your possession, right? But do you avoid the variable cost? Well, we don't have to fly, so we don't have to, there won't be friction in your helicopter, right? And there won't be, say, gas consumption. So here, then you can see how can we avoid variable cost? By temporarily shut down your business. Okay. So there are two options for this one. One in the short run, one is to shut down temporarily to avoid the cost of operation, which is variable cost. In that case, the firm only sustains fixed cost, and profit is the fixed cost that this firm is sustaining, and there is no income because you shut down your business. But the other option is to keep operating. Then this firm has to take on the risk of profiting. What does that mean? Let's look at this. So profit, in this case, composed of two parts, total revenue minus total cost. And total cost is a combination of variable cost and fixed cost. But here, the key thing is you're risking, say, during COVID, people are avoiding exposure to public. In that case, the revenue is pretty low, right? Then possibly the total revenue could be too low, not good enough to cover the cost. The question is, to which extent option B is less preferable to option A, right? If option B is less preferable to option A, then we should decide to shut down, right? So the question is, when should you, as the firm, decide to shut down? Well, we need to do the comparison between these two. And here you can see there is a common term, which is next fixed cost, negative fixed cost. Then the key question is whether total revenue can cover variable cost. The idea of this is pretty fundamental. That is to say, no matter you shut down or operate, you still have to cover the cost of the facility anyways, right? So in this case, fixed cost then will not function in changing your decision. Then what really matters is to compare total revenue versus variable cost, because total revenue is the gain, actual gain from operating. The variable cost is the additional loss in the cost by operating, right? Given that fixed cost, considering that fixed cost is a cost that you can't avoid anyways, right? So if the gain from operation exceeds the gain from a loss from operation, then we should decide to operate. Otherwise, not. Okay, so here what really determines whether you should shut down or not is whether total revenue can cover variable cost. Okay, intuitively, what does that mean? Say if you fly per tour, you get $100, but the cost of operation is the gas that you consumed, right, from this flight is higher than 100. Then for you to fly is not a good option. If otherwise, you collect $100 by each flight, but the cost is only $20, then you should go ahead and do this. Considering that no matter you fly or not, you can't avoid, the maintenance of the plane, the rent of the helicopter, the registration fee of the helicopter anyways, right? Then the fixed cost of holding this helicopter under your possession will not change your decision between shutting down or operating and operating. Okay, so here, then we can have a better idea of this. Let's look at the 2 points. The 2 most important points. One is the point where marginal cost intersects with average total cost. And in that case, the optimal quantity should be the intersection point where say if the price is also at this intersection point, what happens? In that case, say the market price is also 2.5, then price is the marginal revenue intersects with marginal cost. This point, the corresponding quantity of this point is your optimal decision on production. At that time, what happens? Well, in terms of profit, now we're looking into revenue. Revenue is also this line, since we assume this is the price, right? So the rectangle is where my mouse is. The rectangle is where my mouse is, right? That is your total revenue. And also the average total cost is per this level as well. So the same rectangle is also your total cost. In this case, total revenue equals to total cost. So the profit equal to 0. That's why this intersection point, which is also the minimum point of average total cost, that is the break-even point. Okay, if the market price is anywhere higher than this break-even point, you're making a gain. You're making a positive profit. Okay, and when the market price is lower than this 2.5, then you're in the case where you're suffering a loss. Then the question is, what should you do? As you're suffering a loss, there are still 2 options. One is keep operation, even though there is a loss. The other is shut down temporarily to avoid the cost of operation if that's too high and if the gain from operation is too low. So what happens then? So here we're looking into another intersection point, whereas when the average variable cost intersects with marginal cost. This point we refer to as the shutdown point. So if the market price is higher than the shutdown point, then you're making more money. Okay, you're making more money than the variable cost. That is the case where here the total revenue is greater than variable cost. Okay, and when it is just equal, when the price is market price is a horizontal line. When the market price, say, is just locating at the lower dash line, which is 2, in that case, the total variable cost, which is this rectangle, just equal to the revenue, which is P by Q. All right. In that case, you're indifferent between shutting down and operating. But anywhere lower than this, you should decide to shut down. So this actually tells you where we are at. So if the price is between 0 and 2, we shut down, the firm shuts down. If the price between 2 and 2.5, the firm will operate at a loss, even though at a loss. The firm will operate even though at a loss, right? Because what they make will at least cover the variable cost, right? The money that you make is good enough to cover. The money that you make each flight is good enough to cover the gas consumption per each flight. Say you make $100 from each flight, but you pay $20 for the gas consumption. But say keeping this plane each day, it's another $100. Should you keep operating? The answer is yes, right? Because no matter you operate or not, this $100 of keeping this plane under your possession has to be paid anyways. That doesn't enter into your decision then. What matters is whether your total revenue can cover this variable cost. Okay, so in that case, your total revenue, if you're making $100 per each flight and the gas consumption is 20, the difference, which is $80, can be used to pay partially the fee, the cost that you have to incur to keep the possession of the helicopter. So in that case, you only lose $20, which is 80 minus 100. So here, this graph is pretty neat, telling you where we are if the price is at a certain level. Right? Another example is, say, labor market. Right? We all do certain jobs because certain jobs is better paid. Right? We like to do lawyer job, accounting job, right? That's because possibly the pay is here. You can make a revenue, good profit by doing that, right? Say if you invested 4 years in college, but still end up doing, I'm not making discrimination on any jobs, but still end up doing like physical intense job, no different from, say, from those who drop off from high school, right? Then at that time, your cost is too high, whereas your revenue price is too low. Then possibly that's why you don't want to do that kind of job. That's when the price is here, right? So this helps to explain what the firm should do, especially decide between shutdown or operating when suffering a loss. All right, so there is a example question I'll leave for you to go over by yourself. So here, then let's look at the long run. What happens in the long run? In the long run, all firms in a perfectly competitive market should break even. Why is that? Well, say, let's start it with this P1. That's where the market originally was. Okay, so here we have those many suppliers. We are facing a demand, and here this demand is downward sloping because that's the demand for the entire industry. We have talked in previous slides, in previous video. So even though we're not picky on the brand of pencils, but still we need to use pencil. So we have a certain level of reliance on pencil, namely inelasticity, namely steepness of the curve. Okay, so originally, say the market price is a P1, and at P1, as you can see, P1 is higher than the intersection between marginal cost and average cost. So this firm should be making a positive profit under this great market price. That's what when we say the market is good, right? What's the consequence? The consequence is because this firm, because this industry is easy to enter, right? And because this firm is not producing, like I said, it's not making a nuclear weapon. It's not doing anything fancy. It's just a pencil. Anybody can copy that, presumably. If that is the case, people are going to be salty. They can do it. I can do it, right? Then there are going to be more firms enter into the market. And here, we're going to see supply curve shift outwards from S1 to S2. That's because the number of firms increase. And say shifted to S2, where the price equals to P2, and now, well, it breaks even. Will it be possible that it shifts too much to S3, say even lower than S2? It's possible, but the consequence is the price will be too low and the firm starts to suffer a loss. And in the long run, if you're in the industry where you see no hope, where you see you're constantly suffering a loss, then possibly some proportion of supplier will start to leave. And with them leaving, then the supply curve will revert back to S2 eventually. So in the long run, eventually, because of the homogeneity in products, easy to copy, because there's no barrier to entry, right? Eventually, all firm will break even, meaning makes no positive gain, suffers no loss, economic loss. Okay. So that's the short run decision and the long run equilibrium for competitive market.